Okay, so it's finally time to start trigonometry. Now, up till now, we've been talking about similar triangles and applications of similar triangles, and that's all important stuff. Now, the rest of this unit is going to be talking about this idea of trigonometry. Now, trigonometry is going to start with the basic primary trigonometric ratios. Now, what do we mean by a trigonometric ratio? Remember what a ratio is. A ratio is just taking two values and comparing them against one another. And another more simpler way to put it is it's a fraction. We have one value over top of another value. We saw this in the similar triangles when we found our k value, our scaling value. So we took one side and we put it over top of the corresponding side of another triangle. Now, when we have the ratio of two sides of a right triangle, any right triangle, choose any of the two sides, okay? If you have a ratio here, so that means one side over top of another side, we call that a trigonometric ratio. Trigonometry. So trigonometric, this is quite the spelling, T-R-I-G-O-N-E-M-E-T-R-I-C. Trigonometric. That is trigonometric? Yeah, that should be an O here. Trigonometric. There we go. Spelling, not my strong suit. All right, so the trigonometric ratio. So what do we mean by a side? Well, let's try and spell this out for us. Let's say we have a right angle triangle. We know this is a right angle triangle because we can see the little right angle symbol here in the bottom corner. Okay, if we don't see that, we can't assume that it's a right angle triangle. So we have to be able to see that kind of symbology. First thing we're going to do is we're going to choose any angle that is not the right angle. So let's say, for example, we choose angle A. Okay, this is going to be what we call our reference angle. Everything is going to be referenced based on this angle. Okay, now what we're going to do is we're going to label all of our sides relative to that side A, relative to that angle A, I should say. So first of all, we know the hypotenuse is always the side opposite of our right angle. So if we draw a temporary line that kind of goes across here, the side on the opposite of our right angle, this is called our hypotenuse. Hypotenuse. All right. So that is the obvious one. However, the other two sides, these ones go by different names. So we have our hypotenuse, which is always the longest side of the triangle, which is always across from the right angle. Okay, that's key information. Now we're going to label two more sides. We're going to label one side called the opposite. And what do I mean by opposite? It means opposite of our reference angle. So if A is our reference angle, we're going to go to the opposite side of A, and that's way down here at the bottom. This is going to be our opposite side. Okay? And then finally, the third side is called the adjacent. Now, if you don't know what adjacent means, it simply means touching or beside. So it's the side that is touching the angle A, our reference angle. So this is our adjacent. Now, normally when we're labeling our triangle, we don't actually spell it out like this. Usually we'll just use a single letter to reference this. So I'll say, well, this is our hypotenuse, this is our opposite, and this is our adjacent. Let's do it again, but this time, let's go down here and let's make C our reference angle. So C is our reference angle. So that means everything is going to be labeled based on C. Well, we know the hypotenuse is always the longest side, which is across from our 90-degree angle. So this is our hypotenuse. The opposite is always the side that is opposite of our reference angle. So going all the way across there it is. So there's our opposite. There's our opposite. And the only side left is our adjacent, the one that is touching our angle C. The one that is next to it. Okay. So again, use the short form. There's our H, there's our O, and there's our A. You can see from compared to the first triangle, they're actually in different locations. And that's because it's always relative to your reference angle. The opposite is always across from your reference angle. The adjacent is always touching your reference angle. So when I say a trigonometric ratio, what I'm talking about is take any two of the sides, and that's a trig ratio. So for example, I might have opposite over adjacent. That would be a trig ratio, or hypotenuse. Okay, let's say opposite over hypotenuse, right? Or maybe I have adjacent over hypotenuse, right? So we have all these different trig ratios. Now, the thing is, every one of these has a name. And we're going to use these trigonometric ratios to help us solve our triangle. Now, remember, when I say solve our triangle, I mean find all of the missing angles and find all of the missing side lengths. So all the angles and all of the sides. Now, as I said, there are 3 core primary trig ratios, primary trigonometric ratios, 3 of them. And they go by the name sine, cosine, and tangent. Sine, cosine, and tangent. So sine, cosine, and tangent. Now, there's reasons behind those names. We're not going to get into that today because that's part of something else later on, but it's not really the point. Normally, we will shorten these down to just sine spelled like this, cosine, just as in cos. Ugh. Let's just cancel that one out. Let's try this again. This will be cos. And then for tangent, we'll just write tan. Sine, cos, and tan. Now, each one of those is one of these ratios. So, for example, sine is always the opposite over hypotenuse. Cosine is always the adjacent over hypotenuse. And tangent is always opposite over adjacent. Now, we've come up with a quick little memorization tool to help us remember what is what and which sides go with which trigonometric ratio. So, the memory aid that I want you to use is the phrase SOHCAHTOA, 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 SOHCAHTOA. Say it in your mind, say it again, say it 10 times, say it 20 times, say it 500 times. SOHCAHTOA, okay? So when I say so, what I'm saying is it's the sine, which is opposite over hypotenuse, which we can see right here. Cosine, which is adjacent over hypotenuse, which we see right here. And TOA, which is tangent, which is opposite over adjacent. So we see these values right here. Now, you're looking at this and you're like, whoa, there is something else written there, Mr. Lane. What is that symbol right there? What is that symbol right beside the trigonometric ratio? What is this? Well, that is a theta. Theta is a Greek letter that we use in place of an angle. So theta is kind of like a circle. We just keep following that circle around, and then we draw a line right through it. Right? My autocorrect on OneNote here kind of fixed it into like a perfect circle. But normally we just kind of draw it really quickly like that. Okay? This is what we call a theta. And theta is the Greek letter that we typically use for an angle. Well, which angle are we talking about? We're talking about our reference angle, whichever reference angle we are using. Now, maybe that angle is something we're choosing from the triangle. Maybe it is something from the question itself, and it specifically specifies it. Okay? So we have sine of some angle is going to be equal to the opposite over the hypotenuse. Okay? Cosine of some angle is equal to the adjacent over hypotenuse. Tangent of some angle is equal to the opposite over adjacent. These are 3 primary trig ratios. I must emphasize the term primary because there are some more trigonometric things that we're going to be learning later on in the unit that aren't the primary trig ratios. So, to use these trig ratios for this lesson, we need to use our calculator, and you need to make sure your calculator is in the correct mode. Now, you need it to be in degree mode. Now, sometimes you'll look at your calculator and you'll see it as DEG. This typically means it's in degree. So this is what we want. What we don't want to see is RAD. That's for radians, or GRAD. It's something else altogether. So we don't want either of these. We want degree. Okay? And that's going to make sure that when we do our calculations, it's actually going to calculate our angle. That's really what's happening here. So with this tool, we're either going to be calculating one of the lengths of the 2 sides that are part of the trig ratio, or we're going to be calculating the angle itself, which is going to be tomorrow's lesson. Okay? So how do we actually use these? Well, we use sine, cos, or tan. It should be directly on your calculator. Now, depending on your calculator, you will usually have to press the button sine or cos or tan, and then you're going to follow that with a value, and that value is going to give you the answer that we're looking for. We'll come back to that in a minute just to kind of walk you through that. So we're going to use these buttons on our calculator that appear like this. So let's try this out. Give me 1 second. Let's kind of scroll down here a little bit so we can see everything. Now, sorry about that. I paused the video because I was hoping I'd be able to pull up the Windows calculator, but for some reason it's not letting me show it up in the screen recording. But anyways, pull out your calculator. And for this first question, what we're going to do is we're going to type in the trigonometric sine, cos, or tan, and then we're going to follow that with the angle that we're given. Now, what this is actually calculating is the result of this ratio. All right, so when you do sine of 45, so for example, I'm going to pull up my calculator. I'm using the computer calculator. Like I said, you can't really see it on your screen, but just so I can do this, I'm going to say sine of 45. Oops. Sometimes on your calculator, depending on your calculator, you may have to type in the number first and then hit sine, which you have to do on the Windows calculator. And when you do this, you end up with a number for this one, for example, that is approximately, let's do 3 decimal places, 0.707. What does that actually mean? What is that 0.707? That is the answer to this division up here. So this value is the answer to this division. So if you took the opposite side of whatever triangle this is applied to, and then divided that by the hypotenuse, you would get a value of 0.707. That's what we're talking about. So that's the sine 45 degrees. Now, when we created this course outline, this course pack, there were certain sacrifices we had to make when we were creating this. When you're writing out your sine, cos, and your tangent, typically speaking, we want to surround the angle itself in a set of brackets. So typically we'll write it like this, where there's a set of brackets around the actual angle. I'm not sure why they're not here, but that's typically speaking what we want to do, because there may be some form of expression or operation that's inside those brackets that matter. So for the rest of these, what I want you to do is I want you to take your calculator out and just try these out. So try them out on your own, pause the video, and give it a go. So take your angle and then apply it to the trigonometric term that we're using here, sine, cos, or tan. So when I do this, cos 35, I get a value of, hopefully your video is paused right now, drum roll, approximately 0.819. When we do tangent of 20 degrees, we get a value of approximately 0.364. And again, all that is the result of this calculation up here. That's really what we're calculating, okay? So now let's apply this to an actual problem. So it says find the length of the indicated side. So we have an angle. Angle A is 50 degrees. We have one side, which is the hypotenuse, and we're trying to calculate the A. So here is the steps, okay? Everybody follow along. First thing we're going to do is we have to choose our reference angle. Well, we're only given one reference angle, so that's this one. That's the 50 degrees, okay? Now I want to label my triangle in terms of opposite, adjacent, hypotenuse. I know the hypotenuse is always opposite of the 90 degrees. The opposite is always the side that's opposite of our reference angle. So that would put it over here. And that means that this is the adjacent. So now what I have to do is I have to look at the information given and say, what operation should I choose? Sine, cos, or tan? So that all depends on what I'm looking for and what I have. So in this case, I have the hypotenuse, but I'm looking for the opposite. So I'm dealing with O and H. So then I go to SOHCAHTOA and say, well, which ones have O and H? Oh, sine has O and H. So that's the term I'm going to use. That's the trigonometric ratio I'm going to use. So I write it as so. Sine of our reference angle, in this case, 50 degrees. You don't always have to write the 50 degrees in here. In fact, typically I'll just write sine of 50. Okay? So sine of 50 is, what's that equal to? It's equal to opposite over hypotenuse. All right, so let's fill that in. Sine of 50 is equal to our opposite, that's our A value, that's what we're looking for, over our hypotenuse, which is 18. And hey, look at that. It's an equation. We got to isolate and solve for A. So I'm going to multiply both sides by 18. So that means I have 18 times sine of 50 is equal to A. And when this is all said and done, A is going to be approximately equal to, now it says to the nearest unit. So that's the nearest whole number. Okay, so it's not no decimal places. So it's just going to be A is equal to approximately 14. We see it's centimeters here. And that's our answer. So A would be 14. A quick little check says, is it smaller than the hypotenuse? Yes, it is. Okay, that's a good sign. If it were larger than the hypotenuse, I know I made a mistake because the hypotenuse always has to be the biggest side. So we look over here on the other side again, and we do the same idea. First, find our reference angle. Reference angle is the 40. Now we label our triangle. Hypotenuse is always the one across from the 90, and our opposite is always the one across from our reference angle, and the other one is our adjacent. So now we got to look and say, well, what letters do we have and what letters do we need? Well, I'm trying to find E, which is the adjacent, and I have the opposite, which is 50. So I'm looking at this information. So that means O and A. So SOHCAHTOA. That means, oh, opposite and adjacent. That means I'm dealing with tangent. So I write out my equation. I'll write it over here. So we have tan of our reference angle, which is 40, is equal to our opposite over our adjacent. Now, you don't have to write this O over A or the O over H every single time. I'm just doing it the first time so we understand what we're actually doing here. Remember, SOHCAHTOA. Best thing in the world at this point in your stage. Okay? So now we're filling all the information. So we have tan of 40 is equal to the opposite, which is 50, over our adjacent, which is E. E is what we're trying to calculate for. Okay, so I need to isolate for E. Well, that means what I'm going to do is I'm going to multiply both sides by E here. I'm kind of cross-multiplying if you think about it. If depending on how you like to go about these things, I can look at this in one of two strategies. I'll do both strategies so you can see them both. All right. If I want to cross multiply, that's kind of thinking of tan 40 over 1. And that would be E times tan 40, which is E tan 40, equals to 1 times 50. Okay. And then I need to isolate for E. So that just becomes E is equal to 50 over, divide both sides by tan 40. Okay. Really, that's the same thing as what we were doing over here. If I want to, without thinking about the cross multiplying, really I'm trying to isolate for E. That means I got to get rid of E on this side, and I got to bring it over to the other side. So to get rid of E here, that means I got to multiply both sides by E. So when I multiply this side by E, these E's cancel out. And then when I multiply this side by E, it just stays there. So we end up with E. Oops, let me just undo that. We end up with E tan 40 equals 50. Oh, it's the exact same thing we had there. So whichever one you're more comfortable with, do it. They're both the same thing at the end of the day. So we end up with E is equal to 50 over tan 40 again. So what do we actually get when we do this math? You got to plug it into your calculator. Lots of practice with your calculator, just like last unit. And what you end up with is a number of approximately 60 meters. Meters? Yes, meters. It's a big triangle. Okay. So that's what we're looking at to do here. So let's keep going. Let's go down to the next page here. See how we can keep going. So C and D, just more of the same. Right? So you'll notice in this one, in D, we actually have two unknown values. We have two sides that are unknown. That means we're going to have to do twice the amount of work. But it's still the same work. Oops. There we go. Okay. So I'm going to look at this and I'm going to say, okay, there's my reference angle. I'm going to label my triangle hypotenuse, opposite, adjacent. Now that means that I'm looking at, I have the adjacent and I'm trying to calculate the hypotenuse. So AH. SOHCAHTOA, I'll write it over here again. SOHCAHTOA. AH. Oh, That's ca. So that means cosine is equal to adjacent over hypotenuse. All right, so we can write this out. So cos of our reference angle, which is 40, is equal to our adjacent, which is 13, over our hypotenuse, which is little h. Now we need to do the exact same thing we did last time. We're going to multiply both sides by h, and then we're going to have h cos 40 is equal to 13. Now we're going to divide both sides by cos 40. H is equal to 13 over cos 40. And we end up with h is approximately equal to 17 meters. There we go. Same idea over here. Now I know the triangle's tilted a little bit, but that doesn't make a difference. We still follow the same rules. Reference angle 37. Label our triangle hypotenuse, opposite, adjacent. Now let's decide what we're going to go for. Let's say we're going to solve for z first. So that means we have the hypotenuse, and we're looking for the hypotenuse, and we have the opposite. So that means that we are going to use sine, because we have opposite and hypotenuse. Okay, so we have sine of what? Sine of 37 is going to be equal to our opposite, which is 9, over our hypotenuse, which is z. Just kind of fix that up a little bit. So we're going to isolate for this. So we're going to z times sine 37. Now, if you can do this in less steps, absolutely do that. Sine of 37 equals 9. So that means z is equal to 9 over sine of 37. And when you do this, z is going to be approximately equal to 15 kilometers. Another gigantic triangle. Okay, 15 kilometers. And that's great. So that means we have z, we have o, and now we need y. So in that case, if we have o and we're looking for a, let's do a different, can I change my color here? No, I can't. Oh, maybe I can. Let's say, I don't know, blue, right? Oh, I guess it's aqua, whatever. Now I have O and I'm looking for A. So OA, oh, that's tangent. Okay. Let me fix that back up. I don't like that color. Okay. So now, since this one is TOA, that means we're looking for tangent. So we have tan of our reference angle, which is 37, is equal to opposite, which is 9, over our adjacent, which is y. And we end up with, if you notice, the shortcut here is your answer is going to be y is equal to your current numerator, which is 9, divided by the value on the left-hand side of the equal sign. So tan of 37. So what do we end up with here? Y is approximately equal to 12 kilometers. So we can use these trig ratios to calculate any side length we want. We just have to fill in the data and solve for the unknown variable, and that's the whole thing. So let's take a look at our first word problem, word problem. Given an isosceles triangle with two angles of 50 degrees each. So let's imagine our triangle is like such. So two angles of 50 degrees. So that means there's going to be 50 and there's going to be 50. How do I know it's those angles? Well, because I said these are the same sides, the isosceles sides. So in order for this to work, remember the rule, isosceles triangle theorem says that the two matching angles are in the bottom corners. Great. That also means that I know the value of the angle up here. How do I know that? Because I know a triangle has 180 degrees in it. So that means that up here would be 180 minus 100, which would be 80 degrees. But I don't actually need that for this question. So we're just going to get rid of that. So let's go back to our description. Given an isosceles triangle with two angles of 50 degrees each, if the height of the triangle, that's the line straight down the middle. If the height of the triangle is 8.5 meters, okay, find the length of the two equal sides. So what am I actually looking for here? I'm just looking for the length of these edges down here. Is this a right angle triangle? No, it's not. However, However, if I just look at half the triangle, let's say, for example, I'm just looking at the side on the left-hand side here. If I redraw that, I could draw it like so. I know because I dropped that height line straight down that that's going to be 90 degrees. Now it's a right angle triangle. I also know that that side is 8.5 meters. I also know that the angle down here is 50. And our goal is to find the side over here. Oh. All right, so let's do a let statement to start off. This is a word problem. So let's say let x be the length of the equal sides. Let x be the length of the equal sides. There we go. So that means our x is right here. So we look at our triangle and we have to label it. So let's say, for example, this is our reference angle, which is 50. We know that the side opposite the 90 is hypotenuse. That means this is opposite, and down here is our adjacent. So what are we looking for? Well, we have our opposite, which is 8.5. We're looking for our hypotenuse, which is x. So OH, sine. So that's what we're going to do. So sine of our reference angle, which is 50, is going to be equal to our opposite, which is 8.5, over our hypotenuse, which is x. Now, just like we did before, we're going to cross multiply, and we end up with x is equal to 8.5 over sine of 50. And what you end up with this is x is going to be equal to approximately 11.1, what unit do we have here? Meters. Now, how did I know it was 11.1 meters? Where did that come from? I just did the calculation here. And why did I choose 1 decimal place? Because the question said 1 decimal place. That's it. So we have our therefore statement. Therefore, the length of the equal sides is 11.1 meters. There we go. Okay, we're gonna do 2 more small examples here. So in question number 4 here, solve for x and y. So that means we got to calculate what x and y are. Okay, round the answer to the nearest tenth. That means 1 decimal place. Tenth is 1 decimal place. Tenths. Okay, now we got to look at these triangles here. Now it says calculate x and y. Can I calculate y? Well, the overall triangle here is not a right angle triangle, so I can't really do much with that. So I have to work with individual triangles. Well, we know from the supplement triangle theorem that if this value here is 90, that means the one right beside it is also going to be 90 degrees. Maybe that'll help me. Maybe it won't. I don't know. We'll have to find out. So can I calculate y? Well, if you think about it, all of our trig ratios require at least 1 side length. And we don't have any side lengths at this point. That means I can't calculate y yet. So let's look at x. Can I calculate x? Well, on this smaller triangle, I have an angle. I also have the hypotenuse, and I'm looking for the other side. So yeah, I can actually do this one. So if this angle is if the 42 is our reference angle, that means that this is our opposite side. Down here is our adjacent, and up here is our hypotenuse. So what do we have, and what are we looking for? Well, we have the hypotenuse. We're looking for the opposite. So that means we look at sine again. So we have sine of our reference angle, which is 42. And then we're going to set that equal to opposite over hypotenuse. So that's our opposite, which is just x. Our hypotenuse is 14. I cross multiply, and I end up with 14 sine 42 is equal to x, or x is going to be equal to approximately 9.4, what's our unit? Meters. Oh, so now we actually have 2 side lengths, or we have 1 side length. We have the x value, which means now if we think of this as our reference angle and we relabel our triangle, this is going to be our hypotenuse. This is going to be our opposite, and this is going to be our adjacent. So again, we're looking at sine because we have our opposite, which is 9.4 meters, and we're looking for our hypotenuse. Okay, so we do it again. So we end up with sine of 30 this time is going to be equal to our opposite, which is 9.4, which we just finished calculating. And that's going to be over top of our hypotenuse, which is y. We're going to cross multiply. We're going to end up with y is equal to 9.4 over sine of 30. Doing that calculation, you're going to end up with y is approximately equal to 18.8 meters. And there we go. We've calculated both values. So you notice in each one of these calculations, we're basically doing the same thing. We just got to figure out what we have and what we need, and that's going to tell us which trig ratio to use, sine, cos, or tan. Okay, it's going to be one of the three, at least while we're having right angles. So given any right triangle, is it possible for the cosine ratio, remember what cosine is, I wrote it as cos. I did not write that the way I wanted to. Come on, you guys are supposed to be correcting me on this stuff. So we have ca, toa. So it's asking us, is it possible for the cosine ratio of any angle to be greater than 1? Is that possible? Well, let's think about what that means. Cosine of any angle, theta, which is adjacent over hypotenuse. Is it possible to have a value greater than 1? So what does that mean? For it to have a value greater than 1, that means that the numerator has to be larger than the denominator. Well, what's the problem with that? We know that's impossible because h is our hypotenuse. And by rule, in a right angle triangle, the hypotenuse is always the longest side, which means it's impossible for the numerator to be bigger than the denominator. And therefore, we can never have a right angle triangle to have a cosine ratio greater than 1. It is impossible. So we're going to write this. Since cos of theta is equal to adjacent over hypotenuse, therefore, I guess, you know what, let's follow that up with another since. We'll do that in written form. So since the adjacent side is smaller than the hypotenuse, which it has to be, can't even be equal than the hypotenuse. There we go. The cosine ratio cannot be greater or equal to 1. Greater or equal to 1. It is physically impossible. All right. How about this? Is it possible for the tangent ratio to be greater than 1? So what is the tangent ratio? So since tan of theta, which is, I forgot my brackets down here, tan of theta, which is toa, which is opposite over adjacent. So that would imply that the opposite would have to be bigger than the adjacent. Well, that absolutely could happen, right? Think about it like this. If I had a triangle with the, let's say, like so, and my reference angle is down here, this is going to be the opposite, this is going to be the adjacent, and this is hypotenuse. In this case, the opposite is way bigger than the adjacent, which means my tan ratio is going to give me a value of greater than 1. So there are no restrictions on our opposite or adjacent. We have no restrictions at all. So since there are no restrictions on opposite or opposite and adjacent sides, the tangent ratio absolutely can be greater than 1. It doesn't mean it always will be, but it can be greater than 1. Okay? Basically, whenever your opposite is greater than adjacent. Whenever opposite is greater than adjacent, you'll get a value of greater than 1. Awesome. Okay, so that's our introduction to our primary trig ratios, and right now we use them to calculate different side lengths. Sometimes we're going to have the side lengths and need to calculate the angle. That's what the next lesson is all about. So we're still going to be using the primary trig ratios. We're just going to apply them in reverse order. Okay? So that's it for now. See you at the next one.